Hello, my name is Paul Duddle from Catalyst. We're here today to make a training video on behalf of the Subsidence Forum. The objective of this video is to help train and support people in this type of investigation. We hope you find this film informative and very much hope you enjoy it. Today's site is a semi-detached property built in the 1970s. The scenario is that there is cracking and downward movement on the front corner. Previous investigations by Catalyst have suggested that there is possibly a drainage issue. A CCTV survey has been requested. The first thing the drainage engineer does on site is to introduce themselves to the customer.
Good morning, it's Terry from Catalyst. Morning. Come to carry out a site investigation at your property.
Good customer communication is really important.
Just to let you know,
It can identify important information about the site, such as who is at the property and if there are any access issues that could arise whilst the team are on site carrying out the investigation. It can also help confirm if the drainage has any historical issues such as blockages.
Yeah, if you can try not to use your toilet, sinks, washing machine.
Okay.
Keep the drains empty for me while I give them a clean, all right?
Yeah, can do.
Okay,
Yeah, cheers.
no problem, thank you, I'll crack on.
The drainage engineer checks instruction paperwork and carries out a risk assessment for the work being undertaken. It's important at this stage to confirm the location of the reported movement on the property and what drains need to be surveyed that are within the zone of influence. Once the risk assessment is completed, the engineer can set up the site in line with the method statement. The drainage survey is targeted to within 3 metres either side of the area of concern. This can be extended depending what's found. For example, if the drains are blocked and backing up, or ongoing issues are noted within the drainage system. The engineer vents the system to allow any possible build-up of gases to escape. He then sets up his barriers and camera equipment in line with the method statement and risk assessments. Guarding the manhole against unsafe access is vital to prevent trips and falls. He is then ready to start his targeted drain investigation. Hi Perry, thanks very much for that, that was great. I'm going to take this opportunity now to go through the camera box and discuss the different parts of this box and what they do. For this site, we are using a portable remote reel camera system. This has a video camera on the end of a flexible cable called a reel. You'll notice that the engineer has set up the camera so it's facing the drain he's going to survey. You'll also see the reel has a curved memory from being stored on the cage. So if the camera is set up this way, it travels more easily over joints and obstructions when fed into the pipe. There is a reel guide attached to the cage. This needs to be kept clean so the reel flows smoothly. Some camera systems have a counter attached to the guide. Others, like this one, have the counter on the centre of the cage. The camera head, as you can see, has lights surrounding the lens. These allow us to see what's being filmed inside the pipe. The lights can be adjusted using controls on the remote reel keyboard to give the best light conditions for the particular pipe and drain being surveyed. The camera lens needs to be wiped clean to give a good, clear picture. Surrounding the camera head is a plastic shield called a skid. Skids come in different sizes and are interchangeable, so the correct skid can be selected for pipes of different diameters. Skids have 3 main functions. They protect the camera head. They also help the camera travel over joints by using the chamfer at the front and back of the skid. The skid also centres a camera in the drain. We'll go into more detail about the importance of centering the camera a little later. On top of the reel sits the camera box. This usually has a keyboard for coding the footage, which is viewed on a screen. It also has control keys. These have a number of functions, including dimming the lights on the camera head, zeroing the counter, taking still pictures, and filling in the drainage coding sheet. A calibration check should be done at least once a month to make sure the camera counter is accurate and that pipe lengths are being recorded accurately as well. This can be done by simply pulling the reel out 10 metres, then measuring it with a tape measure. If the meterage is out, the camera can be sent away to be recalibrated. It's very important for cameras to be centred in the drain. It means the axis of the camera is in line with the centre of the axis of the pipe. This is achieved by using the correct skid size for the pipe. If the camera is too high or too low, the images recorded can be distorted. This can make joints appear displaced when they're not. It can also result in errors in the estimation of water levels in the pipe. This can happen, for instance, if a 100mm skid is being used in a 150mm drain. The offset vocal distance also needs to be considered. This changes depending on the size of the pipe. In basic terms, the offset focal distance means the location you're seeing on the monitor screen is not the actual location of the camera. This can be important if you're marking up for a liner that needs to be finished at a precise point, such as a junction or a rest bend, or a patch liner repair that needs to cover a fault in the pipework. The drainage engineer uses a sewer coding sheet to code the pipework in line with the Water Research Council best practice. These record all the data needed to identify the location and structure of the pipe, also any defects found in it. There are many types of coding sheets on the market these days. However, they all do the same basic thing. They record the type of sewer being surveyed in line with the sewer classification codes, the precise location of where a pipe begins and ends, the lengths of pipes in meters, structural design such as laterals, connections and chambers, and crucially, the condition of the sewer, including all defects. The drainage engineer records all this data by inputting specific codes. There are many ways pipes can become damaged. So what is the drainage engineer looking for when carrying out a CCTV survey? Let's have a look. There are many ways pipes can become damaged. They include vehicle pressure, ground movement, physical damage, for example by surface strikes, or different forms of misuse. They can be undermined by leakage or during a one-off blockage. Damage can result from poor installation or inadequate maintenance. Pipes may have degraded through wear and tear. Though we have shown a cause of damage for training purposes, on a subsidence claim, the cause will be reported as subsidence. Usually, a trial hole and borehole has previously been carried out by Catalyst to identify the ground conditions, and this report has identified that the ground has been found to have been influenced by possibly the drainage in the area of concern. We don't have time to go through all the coding defects. However, as part of this training, we'll look at the most commonly used codes. Let's start with joint displacement. Joint displacement is where the pipe is not concentric with the socket of the adjacent pipe. A medium displacement is between 1 and 1.5 times the pipe wall thickness. A large displacement is greater than 1.5 times the pipe wall thickness. An open joint is where adjacent pipes are longitudinally displaced at the joint. A median open joint is 1 to 1.5 times the pipe wall thickness. A large open joint is greater than 1.5 times thickness. Moving on to cracks. A crack is a defect on a pipe that is not visibly open. The pieces have not moved apart. A circumferential crack runs approximately at right angles to the axis of the drain or sewer. A longitudinal crack runs approximately along the axis of the drain or sewer. Multiple cracks are a combination of longitudinal, circumferential cracks that cannot be easily identified and/or individually coded. Spiral cracks are individual cracks that change position as they travel along the pipe. A fracture is a crack that has become visibly open on the pipe wall. Pieces are still in place. Just as the fractures can be circumferential, longitudinal, multiple or spiral. Root ingress is coded in three main ways. Fine root ingress is occasional intrusion of fine roots. Taproot ingress is an individual root thicker than 10 mm. Root mass describes roots that have formed a congealed density. Undermined by leakage is where a drain or sewer is leaking and the escaping water washes away the pipe support, causing the drain or sewer to drop. Collapsed pipe is a complete loss of structural integrity of the drain or sewer. Drawing on experience and an initial visual inspection, a drainage engineer can often make a good guess at the structure of the drainage system at a property like this. First impressions here is that a service pipe down the side of the house picks up the surface water and foul water and then empties into the chamber, with the front corner gully feeding into the chamber independently. The only way to be sure, though, is to carry out a thorough CCTV survey. Based on what we can see in the manhole, the drainage in this property is made up of clay pipes. A CCTV investigation is carried out to assess the pipe condition. On this site, we have clay pipes with rigid jointing method of installation. Traditional cement jointing was where a tarred gasket was used to centralise the spigot in the socket and prevent entry of jointing material into the pipe. More modern jointing methods allow for the rubber gasket to allow some flexibility in clay pipe work. The rigid jointing was susceptible to damage from movement. The manhole has two backdrop shafts entering it. These are consistent with the drainage engineer's initial assessment of the drainage system. You'll notice one drop shaft appears to have been repaired at some point because it has a plastic pipe that comes over the top of the benching. Benching, by the way, is the curved cement structure that helps guide sewage into the outfall pipe. The engineer needs to get the camera over the top of the drop shaft to view the upstream pipe. First, though, let's look at what a backdrop manhole is and why it's used. Drainage has to be set up at the correct gradient to function correctly. If the fall is too shallow, the water hasn't got enough force to move the solids in the drain. Again, this can result in a blockage. If the fall is too great, water runs away too fast. This can leave solids behind, increasing the risk of blockages. If the sewer is deeper than the gradient allows, then a drop shaft or a series of drop shafts can be installed to get the pipework to the required depth. It's worth looking at the design of a drop shaft and the issues that can arise as a result. The drop shaft at this property are referred to as backdrop shafts because they run into the back of the manhole. Drop shafts are near vertical pipes. Because of this, they are susceptible to ground movement, resulting in the pipe becoming fractured. These faults are most commonly found just before the point where the pipe drops into the manhole. This is the point of greatest structural stress in the pipe system. The engineer introduces a camera into the rodding eye of the drop shaft. He first tries to carry out a survey without cleaning the pipe. This is to see if a blockage, especially in the surface water pipe, is causing a leak further up the system. If jetting was carried out first, this detail would be lost. In this case, it's clear from the number of roots and other materials in the pipework that water jetting will be needed. Before we start jetting, let's have a look at the jetting equipment and explain what it does.
Hi, so we're going to take the opportunity to show you the back of the engineer's van and the jetter unit that we use for clearing the drainage if you need to clear the drains or if you need to wash the drains through so we can carry out the CCTV. You can see here this yellow hose. We use this to fill the tank up. You'll see a reservoir tank at the back. So this is usually connected to the outside tap if the customer's got one, and we fill the tank up. Once the tank is full, we can then start the system. This reel here is the jetting hose. You can see here that we've got what we call a leader hose at the front. This is used, you can notice it's a different colour. This basically lets us know that when we're pulling the jetting hose back, that that we've nearly pulled it back out the drain, because you don't want to pull it out while it's under pressure and have a jetting hose flying about everywhere. So you can see why that's blue, a different colour. If I take you across to here, you can see this is a pump itself. So the pump is used here. This is your on-off switch for the pump. So as we engage the pump and pull it across, this then puts the pressure through the actual jetting hose. You notice at the end here of a thread, this thread is used to connect depending what kind of jetting hose nozzle we want to put on, whether we're cleaning, root cutting, desilting, whatever you're wanting to do at the time. So I'll take you across to here. You can see on this side here we have the throttle. So once we've actually got the jetting pump turned on, we'll then turn the throttle up to whatever the engineer wants at the other end to actually clear the system that he's using. Across from the throttle there, you can see now the pressure gauge that we've got. On the side here is your dump valve, so you should be dumping your water in the right place. So make sure that your tank isn't full when you're leaving site, making sure your vehicle isn't overloaded. And most importantly, you've also got your emergency stop switch. So if everything's going wrong, you can hit this switch and that turns the whole system off. Hope that's useful to you.
When the drain needs cleaning, the engineer carries out a risk assessment and sets the site up accordingly. The engineer must choose the correct type of nozzle so jetting is carried out safely and effectively. A line of communication needs to be agreed before jetting starts with the engineers. This is usually a set of standard hand signals. With the jetting pump running and PPE on, they are not likely to hear each other. PPE includes waterproof clothing, including a jacket, trousers, boots and gloves, a helmet with a full face visor, as well as ear defenders are essential. When jetting upstream, drainage engineer must keep an eye on what's coming through the chamber and remove any materials that might cause a blockage further downstream. Now the pipework is jetted clean, the engineer can start the camera survey. At this point, this property threw up a bit of a surprise. It was found the pipe connections were actually quite unconventional. Unusually, the two surface water gullies were connected to one service pipe, while the foul system for the toilets and kitchen waste were connected to a separate pipe, with both independently entering the same chamber. Without carrying out a drain survey, this unusual configuration would not have been easily identified. The engineer must now inspect the gully, a task that is often overlooked. But first, what is a gully? A gully is a small chamber where water is trapped before it's allowed to flow into the drainage system. What does a gully do? It prevents smells and gases escaping from drains. It stops vermin, and it catches debris before it can enter the sewer system, preventing possible blockages. By their design, gullies are prone to blockages as debris builds up in the trap. For kitchen and utility gullies, this can include fats and grease from kitchen sinks and detergent residue from washing machines and dishwashers. If a trap becomes blocked, wastewater can back up the system and go to ground, creating a subsidence risk. This tells us regular inspection and maintenance of accessible drainage can prevent avoidable blockages that can have serious consequences. There are many types of gullies. This one is a clay gully with a trap at the bottom and a gully head installed on the top. So it's actually two separate pieces. It's important at this stage to check the conditions of the gully. So it's holding the correct water level in the trap, that there are no fractures or breaks in the gully head is not damaged or cracked, the jointing between the trap and the gully head is watertight and not leaking, that the downpipe is introduced into the gully correctly, that the cement flaunching around the gully is in good condition. Also check if the wall looks damp or has plant growth due to water leakage and seepage. In this case, we found that the gully was indeed blocked. By carrying out a water test, the engineer found water was escaping, but not down the pipe. Instead, it was seeping down the sides of the gully pot and into the ground. If left unchecked, this would add to the subsidence risks. An initial solution was to clear the blockage with a plunger. However, further repairs to the gully are likely to be needed. The importance of water testing to check for leaks from sewer pipes is often also overlooked. If soil testing or a visual inspection indicates that the ground around a drain is unusually soft, a low-pressure water test should be considered. This is done by inflating an airbag in the section of pipe you want to check. You will need access to insert the airbag downstream and a visual on the water level upstream. Another important task is to check the gully connections. This establishes where the water it takes comes from and who derives the benefit. As we can see, this is a shared gully. It takes water from our customers' gutters and those of their neighbours. Both properties derive benefit from the same drainage system. Therefore, as it's shared, it's a responsibility of the local water company to maintain serviceability. Where excavation work is required, it is important to identify the location of the pipe repair. One way to do this is to use a cat and sonde. The equipment consists of a sonde, which is a radio transmitter, usually situated at the rear of the camera head in modern camera units. This sends a signal to the cat detection device, held by the drainage engineer. By sending the camera along the pipe, the engineer can locate the sonde above ground, so he can be absolutely sure of its location. On completion, all equipment is removed from site, manhole covers and gully grates replaced, and the customer is informed that the investigation is complete.
Hello, you're right.
Hiya.
Just to let you know, we've completed the survey now.
Great. Yeah.
Put everything back to where it was for you.
Okay.
And you should receive a report from the office.
Catalyst supplies a full report. This includes the scope of works and costs for any repairs required. In this case, the survey report identifies the manhole 1 upstream run on the foul system is private and the responsibility of the homeowner. It notes the policyholder has not reported any issues with blockages. The survey report reveals a pipe has the following defects: root ingress, displaced joints and cracks. Remedial work the report recommends is a partial excavation and lining of the run. The survey also notes the structural engineer may feel the damage on this section is outside the zone of influence. The report also identifies issues relating to manhole 1 upstream to rainwater gully 2. It finds a pipe is part of a shared surface water system and therefore the responsibility of the local water company. It reveals a pipe has the following defects: cracks, a defective junction, displaced joints, root ingress and mass silt. Repair recommendations are to carry out partial excavation and lining of the pipe, with work to be carried out by the local water company. Rainwater Gully 1 was found to be blocked and water discharging to ground in this area. A water test was carried out and the gully failed. This is within the zone of influence and is possibly contributing to the subsidence. You can see how important it is to carry out a thorough drainage investigation. The investigation highlighted the unexpected, with the slightly unorthodox drainage system set up. Without doubt, the main culprit for the subsidence to this property is the shared rainwater gully and pipework on the front corner, which takes a large volume of water from not only the policyholder's roof, but also the neighbours. Catalysts would assist in discussing the issues found with the local water company to get the correct repairs carried out. Private repairs on other sections would, once confirmed by the structural engineer, be carried out by Catalyst. It just leaves me to say thank you for watching. I hope you found this training film informative and helpful. Catalyst hope to see you at a live event in the near future.